In this video, we will introduce what fundamental units are and how we can use these to find derived units, which is a common IB physics exam question. Now, a fundamental unit can be thought about as a base quantity. Now, this means that they cannot be expressed in any other form, and they are essentially in their simplest form. Hence, they are called fundamental. Now, if you look on the screen here, I have attached a table with all the fundamental units along with their quantities and symbols. It is important to remember these quantities for the IB physics exam, as it is a common IB question to test your understanding on fundamental units. There are a total of 6 fundamental units that we need to know, starting off with mass, followed by distance, time, electric current, amount of substance, and temperature. Now, all of these are known as fundamental units because, as I said previously, they cannot be expressed in any other units, hence they are known as base values. Now, an example of a non-fundamental unit, which we call derived unit, could be velocity. Now, why is velocity a derived unit? So we obviously know that the formula for velocity is distance divided by time, which means that the units of velocity is meters per second. Now, as you can see, the unit is meters per second, which comprise of both the fundamental units of distance and time. I hope that makes sense for you, but if it doesn't, it's okay. Because now we're going to walk through a very simple question about how to take a derived unit and change it into its fundamental constituents. Now, this is quite a common IB question, so let's get started. Okay, so in this example, we're gonna walk through how to express the unit newtons, which is a derived unit, into fundamental units. Now we know that newtons is the unit of force. So this is the quantity we are looking for. And we know that force can be expressed as mass times acceleration. So the first step to tackle this question is to first take your unit and change it into the quantity. So the unit in this case is Newton and the quantity would be force. Next, we can either look through our formula booklet or try to find some sort of formula that works that express the quantity into other terms. So we have force is equal to mass times acceleration. We know that mass is a fundamental unit, so we can leave it there. Now, here's the thing. We have to keep repeating this process until we reach a formula that just consists of fundamental quantities. So mass is already a fundamental quantity, so we can leave it alone. But acceleration is not. Acceleration is velocity over time. So time is a fundamental unit, but velocity is not. So velocity is also equal to distance over time. Now, distance is a fundamental unit, and so is time. So this works out. Now we just have to substitute that, so we get acceleration is equal to distance over time squared. Now, I'm just going to walk through the maths up here. So imagine you have dt over t, time. Now, this will come down when you're dividing fractions, and that gives you this. So this means that acceleration is equal to distance divided by time squared, which means force is equal to the mass times the distance over time squared. So this is the formula for force, and this is in the quantity. We're looking at quantities here, and now we need to find what the units are. So surprisingly, by using this formula in terms of quantity, we can directly convert that into our units. So we know force has a unit of newtons. So newtons is equal to mass, which is in kilograms, multiplied by distance, which is in meters, multiplied by, now this would be second to the power of minus 2. When you add a minus, remember your exponents, minus would mean that it's actually getting divided by. I mean, put by minus 2 because it's divided by t to the power of 2, which means minus 2. And time, the unit is seconds. So now we can perform a check that kilograms is a fundamental unit, mass is a fundamental unit, and so is seconds, which means our final answer, newtons, can be expressed as kgm s to the power of minus 2. Okay, now that we've done that example, let's move on to a trickier question. And this question is approximately the same level you'll find in a real IB exam. This is question 17 from our topic 1 question bank. So in question 17, we are asked to derive the unit joules as a fundamental unit while showing our working. So we know that joules, and thankfully it's given here in the question, that the quantity of joules is energy. So now we have to think about what formula or in what ways can we express energy. So we know that the work done is also energy, is equal to force multiplied by distance. Now we know that distance is already a fundamental quantity, so we can leave that alone. And force is equal to mass times acceleration. Now, what we could do is that we can actually go and work out what acceleration is by going through all the steps. So acceleration is equal to velocity over time, and velocity over time is equal to more fundamental units. But we can actually skip that step and just instantly substitute that in, because we know the fundamental units of acceleration by heart. And this is what we get for work. So let's just substitute in our fundamental units. So we know work is in energy. So I'm just going to write energy, which is actually in joules. And mass is in kilograms multiplied by acceleration. So acceleration is the change in velocity over change in time. So we know velocity is meters per second. So this would be a -1, but it's over a change in time, which means to the -2. And here we have a distance term, which means we multiply it by another m. Now, when you have fundamental units like this, the units actually multiply each other, just like in maths. So we have kilograms, m to the power of 2, and seconds to the power of -2. And that is our answer for question 17, which is basically joules re-expressed in fundamental units. Now that's it for this topic, and I hope you learned something new today in this video. Remember to like and subscribe, as I'll be posting more explanations on this channel, as well as past year paper solutions.